So we need to determine the limiting value of this given function when n tends to infinity. In the numerator, we have the sum of the natural numbers, and there are n number of natural numbers divided by n squared. Now when we use the limiting value, so that means we have infinite number of natural numbers in the numerator, and which when added up will give us an infinite number at infinite value divided by infinity squared, which is again infinity. So that means we are getting an indeterminate form, which is infinity over infinity. However, we know that when we sum up to n number of terms, the sum is given by n times n plus 1 over 2. So we use this value and substitute into a given function. So we have limit n tending to infinity. So in the numerator we have n times n plus 1 over 2 whole divided by n squared. Now we're going to take n as the common factor from n plus 1, so that will leave us with n squared times 1 plus 1 over n divided by 2n squared. So we take n squared as the common factor and cancel it out from both the numerator and the denominator. So that is going to leave us with limit n tends to infinity. So we have 1 plus 1 over n divided by 2. Now we substitute for the value of n, so we have 1 plus 1 over infinity divided by 2. So 1 over infinity, that means 1 divided by an extremely large number, so then the value will tend to 0. So we have 1 in the numerator divided by 2. So this is going to be the limiting value of the given function when n tends to infinity. So we need to determine the limiting value of the given function when n tends to infinity. Clearly we have sum of the squares of n natural numbers. So when there are infinite number of terms, then we have infinity in the numerator divided by infinity cube, which is infinity. So this is giving us an indeterminate form of infinity over infinity. Now however, when we sum the squares of n natural numbers, then this sums up to n times n plus 1 times 2n plus 1 divided by 6, which is equals to n times, so we're going to take n as the common factor, so we are left with 1 plus 1 over n. Again, we are going to take n as the common factor from 2n plus 1, so we have n times 2 plus 1 over n divided by 6. So this is going to give us n cube over 6 times 1 plus 1 over n times 2 plus 1 over n. So now we substitute this value back into our function. So we have limit n tending to infinity. We have n cube over 6 times 1 plus 1 over n times 2 plus 1 over n. And we also have an n cube in the denominator. Clearly this n cube gets cancelled out from both the numerator and the denominator, leaving us with 1 plus 1 over n times 2 plus 1 over n and 1 over 6. Now we substitute for the value of n, so that gives us 1. So 1 over n will be 0 times 2 plus 1 over n. 1 over n will be 0, so we're left with 2 times 1 over 6, and this gives us the final limiting value of 1/3. So here in this question, we have the sum of the cubes of n natural number divided by the 4th power of n. So when we substitute for the value of n with infinity, so that is going to give us an indeterminate form of infinity over infinity. So we'll have to do some manipulation here. Clearly we know that when we sum the cubes of n natural numbers, so that is going to give us the value n times n plus 1 over 2 whole squared. So that is equals to n squared over 4 times n plus 1 whole squared. So we're going to expand n plus 1 whole squared by using the identity a plus b whole squared is equals to a squared plus b squared plus twice of ab. So we have n squared plus 1 plus twice of n, and then we multiply n squared to each of the terms. So we have n raised to the power of 4 plus 2n cubed plus 1 plus n squared. Now let us substitute this value back into our function in the numerator. So we have limit n tending to infinity. So we have 1 over n raised to the power of 4 multiplied to 1 over 4 times n raised to the power of 4 plus 2n cubed plus n squared. Now what we do is we look for the highest power of n in both the numerator and the denominator, and that is 4. So that means we have to divide the numerator and the denominator by n raised to the power of 4. So that is going to give us 1/4 of 1 plus 2 over n plus 1 over n squared. Now we substitute for the value of n. So we have 1/4 of 1 plus 2 over infinity is 0, and 1 over infinity squared is also 0. So this is giving us a limiting value of 1 over 4. So we have to find out the limiting value of the given function when n tends to infinity. So let us rewrite the given function. So here we have limit n tending to infinity. So we're going to take 1 over n squared as the common factor. So that will leave us with 1 plus 2 plus 3 all the way up to n plus 1. So that means we are adding n minus 1 natural numbers. We know that 1 plus 2, so we know that the sum of n number of natural numbers is given by n times n plus 1 over 2. So if we have, and for n minus 1 number of terms, so that is going to be equals to, so we're going to substitute n with n minus 1. So we have n minus 1 times n minus 1 plus 1 over 2, and this is giving us n times n minus 1 over 2. So we have limit n tending to infinity, we have 1 over n squared times n minus 1 divided by 2. Now we look for the highest power of n in both the numerator and the denominator. So that is going to be n squared. So we're going to divide both numerator and the denominator by n squared. So that is going to give us 1 into 1 over n. So this is simply 1 minus 1 over n divided by 2. Now we're going to substitute for the value of n. So that will be equals to 1 times 1 minus 0 divided by 2. So we get the limiting value of half. So here we have to determine the limiting value of the given function when n tends to infinity. Now if we look at each of the terms in the numerator, we see that the highest power of x is 10. So we are going to divide the highest power of x is also 10 in the denominator. So we're going to divide both numerator and the denominator by x raised to the power of 10. So that is going to give us limit n tending to infinity. So we have, when we divide the first term by x raised to the power of 10, we have 1 plus 1 over x whole raised to the power of 10. Now for the second term, we have 1 plus 2 over x raised to the power of 10. The way it is done is like we have x plus, I'll talk about the first term. So we have x plus 1 raised to the power of 10. So when we take x as the common factor, so we have 1 plus 1 over x whole raised to the power of 10. Then we have x raised to the power of 10 times 1 plus 1 over x raised to the power of 10. And on dividing by 1 over or dividing by x raised to the power of 10, that gives us the first term, which is 1 plus 1 over x raised to the power of 10 plus dot 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 all the way up to the final term, which is 1 plus 100 over x raised to the power of 10 divided by 1 plus 10 raised to the power of 10 divided by x raised to the power of 10. Now we substitute for the value of x. So here I made a mistake. So this is r x. So this is not n, so this is x. Anyways, so we have 1. So 1 over infinity is going to be 0. So we have 1 plus 0 raised to the power of 10 plus 1 plus 0 raised to the power of 10 plus all the way up to 1 plus 0 all the way 1 plus 0 raised to the power of 10 divided by 1 plus 0. So that means we have in the numerator 1 plus 1. So there will be 100 terms here divided by 1. So we have 1 added to itself, 100 number of times. So that is simply 1 multiplied by 100. So we have the limiting value of the given function is 100 when x tends to infinity. So here in this particular question, we have a series having n number of terms, and we need to determine its limiting value when n tends to infinity. Clearly, the given series is a geometric series. That's because if we look at any one term, it's always the product of 1/3 of the previous term. So what I mean is, if we look at the second term, which is 1 over 3 squared, so that is 1/3 of the previous term, which is 1 over 3. Similarly, if we look at 1 over 3 cubed, so that is 1/3 times the previous term, which is 1 over 3 squared. So we begin by summing up to n terms for the given geometric series. We know that if a geometric series given by a plus ar plus ar squared all the way up to the nth term, which is ar to the power of n minus 1, where a stands for the first term and r is the common ratio that is determined by dividing the second term by the first term. Then we have the sum up to n terms is given by a times 1 minus r raised to the power of n divided by 1 minus r. That's when r is less than 1. So clearly in our given series, our first term is 1 over 3. So we have 1 minus r, which is 1 over 3 raised to the power of n divided by 1 minus 1 over 3. So we have 1 over 3 times 1 minus 1 over 3 raised to the power of n divided by 1 minus 1/3 is going to give us 2/3. So 1/3 divided by 2/3 is half. So we have half multiplied to 1 minus 3 raised to the power of n. So this is the value of s of n. So this limit is actually equals to limit n tending to infinity, sum of the n terms, which is limit n going to infinity. We have half times 1 minus 1 over 3 raised to the power of n. Now we substitute for the value of n, so that means we are adding up to infinite number of terms, so that will be simply half times 1 minus 3 raised to the power of infinity. You can say 3 raised to the power of an extremely large number, so that means 1 minus 1 over infinity. So we know that 1 over infinity tends to 0, so that leaves us with half of 1 minus 0. So the limiting value is equals to half.